Okay, so here's the instructions for the lab number 8. So you can pause this and fill out your spreadsheet. I'll explain what everything is. So we had the 5 different mass values. These are in grams. So we had 20, 40, 60, 80, 100. We had 3 different pulley sizes: large, medium, small. The diameter of the large pulley was 0.048 or 4.8 centimeters or 0.048 meters. The diameter of the medium pulley was 0.9 centimeters or 0.029 meters, and the diameter of the small pulley was 0.01 meters, 1 centimeter. Let's all use the moment of inertia of the disk as 1.36 times 10 to the minus 4. So you can see I have written as equals 1.36 times 10 hat negative 4. And you can see it writes it out in non-scientific notation here. The mass here, which is base mass, that's the mass, the 200 gram masses plus the 2 hangers. So that's the inertia, kind of the base inertia. So that's 210 grams or 0.21 kilograms. And then we have the measurements. So I've taken one student's measurements, and yours should be fairly similar to this in terms of their magnitudes, maybe slightly different. But so these are the large pulley value averages, the medium pulley value averages, the small pulley value averages. So once you get that all entered in, then we can start. So again, like we did with the last lab of the last semester, we're going to compare the theoretical versus the analytical. So let me pause for just a second. So the equation, I think I showed it in the introduction, in terms of linear acceleration, which is what we measured, it equals the mass difference, so it's m2 minus m1, which is going to be the 20, 40, 60, 80, and 100 grams converted to kilograms times g. So that's our kind of driving force. If m1 equals m2, then nothing happens. It doesn't move. Then in the denominator, you have m1 plus m2 plus the inertia associated with the disk. So we've got the moment of inertia of the disk, but we have to divide by the radius of the pulley squared. Now, this m1 minus m2, that's kind of like our delta m. So we'll have delta m times g. So it's, like I said, 20, 40, 60, 80, 100 grams, or whatever the equivalent is, kilograms. We'll convert that in the program. Then you have the two masses together. So what that would be is the base mass plus the delta mass. So this is the 210 grams, and then this is 20, 40, 60, 80, 100. And then we have the moment of inertia of the disk divided by the radius of the pulley squared. And that should be the theoretical calculation. So let's go ahead and do that. So here's for the large pulley. So we're going to do equals. In the numerator, we have the delta m, which is cell A8. And that's going to be incremented, so we're not going to put any dollar signs there. We're going to multiply by 9.81 to get weight. And we're going to divide by 1,000 to convert grams to kilograms. So that's the numerator of the expression. This one right here, delta m times g. Okay, then we're going to divide by base mass, which is over here, L2, but that's going to stay constant for all the calculations. So I'm going to push my F4 key to get dollar sign. Then we're going to add the mass difference. I don't have to divide this by 1,000 because I've already converted it to kilograms. This one's in grams, so I'm going to have to divide that by 1,000 to get into kilograms. So that's the sum of the two masses, hanging masses and the hangers. And then I'm going to take the moment of inertia of the disk, so that's L1. I'm going to use F4 to convert that to $sign because that doesn't change. It's the same disk for all the calculations. Now we're going to divide by the radius, so these are diameters. So let's pick the diameter of the large pulley. Now what I'm going to do there is I'm going to put a $sign after for the 2. Is that right, or do I put it in front of the C? No, I'm going to put it in front of the C. We'll see why in a second. So that's so that when I copy the equation, it'll use these updated values for the different diameters. So it's $sign C2. Because it's always, no, actually, it's the other way around. C $sign 2. It's always going to be the second row, but it's going to go C, F, I, depending upon where we are. So that just makes it so we can copy this equation everywhere. We're going to divide by 2 to get into radius, and we're going to square it, so little hat 2, and I think that should be right. Make sure I've got enough parentheses. So I think I need one more parenthesis. You can see the colors here. These reds match up, so I can convert that to radius, and then this one groups the entire denominator together, and then these two group the numerator. I didn't really need to group the numerator that way, but and I push the enter button, and hopefully it's close to 0.38, which it is. It's 0.42. So the theoretical, again, it might be a little higher because, for one thing, we have that other rotary motion sensor that we were using to separate the two weights from each other. So I didn't take that into account. I assumed it was small. You also have friction associated with the rotary motion sensor. So I'd expect the measured to be less than the theoretical. Okay, so it looks good. So all I'm going to do is click on that cell with the equation. I'm going to just take the corner. I'm going to drag it down. So there's my theoretical. Here's my actual. And then I'm just going to copy this. So highlight those 5 cells, do Control C, go over here and do Control V, and do the same thing here, Control V. And so now we have measured versus theoretical for all 3 cases. Now, the reason I did this where I had the mass in 3 different times is it's going to make it easier to plot this instead of having just this one time, the column with the mass difference. So to do the graphs now, before we do that, let's format these so there's not so many decimal points. So we're going to highlight these cells. We're going to right click. We're going to go to Format. We're going to choose number, 3 decimal places, I guess. So that looks good. Do the same thing for this one. Highlight, right click, Format, number, 3 decimal places. And one more time. Okay. Now, so that's the data. I've already done it because I went through this and now I'm just redoing it now that I knew I did it right. So you rename the tab down here. Just double click it, type in data. So that's your data tab. Okay. Now, what we're going to do is we're going to highlight this. So we got the X, these are the X values, and then we got the 2 Y values. We'll go to Insert, Chart, like the one, just the data points. So there's our chart. And we want to move this to a separate tab. So we'll click inside the chart, right click, choose Move Chart, create a new sheet, and we'll call that Large Pulley. That'll create a new tab called Large Pulley that has the data. Let's do the same. Let's go back to the data, highlight the next three, click on Insert, Chart, Scatter Plot, click on the graph, right click, New Chart, New Sheet, Medium Pulley, and then finally the third group of data, Insert, Chart, Scatter Plot, right click, Move Chart, Small Pulley. So now we got our three graphs. So let's look. So you can see with the large pulley, all of the measured are lower than the theoretical, about the same amount in terms of percent-wise probably. But if you go to the medium pulley, you can see how they diverge here, and that's where slippage is occurring. So the slippage starts to happen here at 60 grams for the medium pulley, and it happens definitely at 60 grams for the small pulley. So that's what we were looking for. You can see for the 20 and 40, they have about the same amount of error or difference. But once you get to the 60, 80, and 100, they start to diverge. Okay. Now we just need to work on our graph. So one thing you'll notice is that the legend says series 1 and 2. So we want to put measured and theoretical. So you go to select data, series 1, say edit. Up here where it says series name, we'll say, I guess series 1 is measured. And then we click on series 2, edit, theoretical. Okay, so you can see they're changed now. Now I don't like the labels at the bottom, so I'm going to click on my little plus sign here. It has a legend, but if you click to the right here, there's a little triangle. I'm going to move it to the top. Okay. In addition, I want axis titles, so I'm going to click on axis titles. I could change the fonts, but I think we'll just skip over that this time. So we just need some labels. So the chart title would be, I'm going to call it so I can get my cursor up there and then I can just delete here. So we'll call it acceleration with large pulley. And the other ones we'll do small and medium. The axis titles are going to be the same. So I've clicked on the title. If you double click, it'll highlight, and then it's a little small, so just be careful when you type. So we have the acceleration in meters per second per second. I could put meters per second squared, but it's just easier to not. So that's acceleration, linear acceleration. Then we go to the horizontal axis, which we'll say is mass difference. And the units are grams. So I think that's about it. Like I said, we could increase the font size to make it look a little bigger. And then we just do the same thing for the others. So this one would be acceleration with medium pulley. We need to change the series name, so we'll go to Select Data, edit Series 1, which is measured, and Series 2, which is theoretical. So now the names are correct. Look at the little plus sign. Change the legend to the top, and we put Axis titles on. Okay. So verification meters per second. And then did I put parentheses? Yes, I did. Down here we have mass difference in grams. So that one's done. And then finally the small. So we get the title. Oops. Change the titles for the series names. Okay. Move the legends to the top. Put the titles on there. Again, same titles. And we're just about done. Okay, so I think that's it. So we got our data, got our pulleys, and again, the main thing we're looking at here is for the large pulley, we didn't have slippage. For the medium pulley, we didn't have slippage for the two smallest masses. And for the small pulley, we didn't have slippage for the first two as well. Okay, that's it. So you can upload it with your numbers.